Hi, everybody. Welcome to I'm Mr. Folly. Oh, no, I'm not writing. I am Mr. Folly, and welcome to 5.1. Yay! All right, so this one is a lot of people's favorite chapter because it makes sense. It comes down to the collision theory, which we've talked about a lot, and it starts off with rate. Okay, so rate is change in something over change in time. The something for us is most often molarity. And remember, molarity is capital M, or molarity would be like K positive in brackets. This is the change in concentration, molarity, not amount. So we're not talking about counting the number of moles, we're talking about the concentration of it. So, and comes down to the fact that rate is how often they collide, all right? Rates can also be determined by the coefficients of the reaction. So let's take a look. So if I have 3Cu plus 8HNO3 yields 3CuNO3 taken twice plus 2NO plus 4H2O. Wow, that's a big equation, all right? So if I have 8 moles per second of HNO3, okay, that would be moles per second, not molarity. How many moles per second of copper are required? So if it takes 8 moles per second, notice how that's my coefficient. This would take 3 moles. Okay, so the coefficient tells us that. How many moles of copper nitrate form in a minute? So notice how I have 8 moles of HNO3 in 1 second times, let me see if I can blow this up a little bit. Oops, that's not zoom. There's my zoom. Okay, so I'm going to make this a little bit smaller. I'm going to go to my finer tooth pen too. So I have 8 moles of HNO3 per 1 second. And I want to find out how many moles of CuNO3 form in 1 minute. Well, that would be 3 moles of CuNO3 taken twice, and for 8 moles of HNO3, right? So notice how my moles of HNO3 cancel out. And if I want to do it in 1 minute, then what's going to happen is I'm going to have 1 minute is 60 seconds, right? So 8 times 8, that cancels out. 3 times 60 is 180 moles. Now notice my seconds cancel out too. So the only unit I have left is moles of CuNO3 taken twice. How many liters of, let's see here. How many liters of NO form if the pressure is 1.25 atmosphere and the temperature is 300 K? So what we're going to do here, okay. So how many liters of NO form if the pressure is 1.25 and the temperature is 300 K? So what we have here is the same thing. We're starting off with 8 moles. So I think we can tell now that 8 moles goes to 2 moles. So I have 2 moles of NO. How many liters of NO form? So this is where we're going to go back to our old friend PV equals nRT. So the pressure is 1.25. The volume is what I'm solving for. My N is 2. R is 0.08206. My temperature is 300. So calculators assemble. Second quit. 2 times 0.08206 times 300 divided by 1.25 is 39.3. So volume is 39.4 liters. All right. So far so good. So just showing you what you can do with this, how the coefficients will deal with the rate. All we're doing is changing it per time, okay? Each rate of reaction can be measured a number of ways. We have color change, colorimetry, and Beer's law. So for example, a reaction could be getting darker or lighter, and we could measure the absorbance at a certain time. Following graph was recorded indicating the absorbance of copper plus 2. Remember, copper plus 2 is blue, all right? So as I go up, it's getting darker. The absorbance is greater, so that means it's getting darker as you go up. So I'm increasing copper plus 2. A equals ABC, and remember, A equals epsilon BC now, and that's the same, right? For that same setup. So absorbance is directly proportional to concentration. Using the above graph, the slope tells you the relative coefficient. Copper would have the same slope. Different starting points are okay. Oh, let's see here. So this is absorbance at 450 times. So there you go. Copper would have the same slope, but different starting points. All right. So let's talk about how we can use these graphs to compare. HNO3 would have a slope 8/3 as large. So let's look at this equation again. Oops, scrolling too fast here. Let's look at this equation again. We have 3. So we're talking about copper nitrate. That would be copper plus 2, right? Right? So these would have the same slopes for their change, okay? HNO3 would be 8/3 as much, and NO would be 2/3 as much, and water would be 4/3 as much, okay? So HNO3 would have 8/3 is larger. Different starting points is okay. So notice the slope is proportional to coefficients. Whoops. Coefficients. Reactants start high and go down. Products start low and go high. Pressure of NO gas can be measured. So that's a pretty easy device to do that. We just have pressure gauges for it. Mass of formation or loss can also be measured. pH can also be measured, as HNO3 is actually ionized H positive and NO3 negative. Remember, it's a strong acid. And pH measures molarity, not amount of H positive. So let's take a look at this graph. All right, all ions. So probably nitrates we're not looking at. Time, we're counting every 30 seconds, 30, 60, 90. Na concentration is going down. Okay, so notice it's not going down by an equal amount. Okay, so it changes, and this makes sense. If you start off fast, then you go slower, blah, 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 blah. So let's see what we can fill in here. Okay, so Na goes from 0 to 0.5. So ClO negative is going to go down by the same amount because they have the same coefficients. Cl negative will go up by the same amount this went down. This is positive 0.50. Okay. And then this one, well, again, the change here is negative 0.1. So this is going to be positive 0.1. Okay. And then cobalt plus 2 is constant all the way through. Sometimes you have things that set a condition for it that don't do anything, so they're not involved. Note that these are molarities. Questions can be leveled up by giving moles in 2 liters of solution, and then you just change into molarities. Note catalysts act differently. It may be a surface catalyst, so its concentration is constant. Cobalt plus 2 would be an example of that. The graph above, many lines, or interpret graphs, many lines should be expected. So, for example, I could have something that would be, right? And you can figure out coefficients and things. Rates of reaction are determined by experiment only. This cannot be emphasized enough, by experiment only. Rates are determined by experiment only. So notice this was an experiment when we measured these. Relative rates can be defined by comparing the coefficients of the reaction, right? That's the coefficients in those ratios to do it. Some reactions that can happen do not happen because they do not have the activation energy. Activation energy is the minimum energy, minimum energy required for reaction to take place. All right. The collision theory, key idea to Big Five, and key idea to that is a core of all chemistry. So you need to know this and be able to spit it out pretty easily. For a reaction to take place, particles have to collide with enough energy, and collide with the correct orientation. Believe it or not, this is the one that is most often forgotten. People remember that the energy is important, they remember the orientation is important, but they forget about the actual colliding part. So be careful. Changing rate is due to collision theory. If you heat a reaction, you have more collisions, and you have more energetic collisions. If you increase concentration, you have more collisions, and that means it's going to go faster. So all of these, you would say per unit time. So increasing concentration would be more collisions per unit time. The per time is what makes it rate. Catalyst, less energy required for more collisions with enough energy per unit time. If you powder a solid, now this one's a little bit different for us. So powder a solid, there's more surface area, so there's more places for collisions, and there's an extreme change in rate. Okay, so kinetics is the rate at which reactants are converted into products. Stoichiometry, converting from one substance to another using a balanced equation. And here we have surface area, part of a substance that is exposed to react. A cube has 6 sides. So looking at this, if it was a cube not cut up, if I cut that cube in half, so if I start with my cube, you know this is 6, right? 1, 2, 3, 4, 5, 6. If I cut it in half, I add 2 more. That means I have 8 sides. That increases the rate by 33%. Do that again, and you keep adding more and more and more and more. And that's it. So, welcome back. 11 minutes out of here. Toodles.